Hello, this is Dr. Hanaa Assil, and this is a video on the past paper for Unit 1 AS Chemistry. This was June 2020, and this is a review on what the questions and answers can be. So, the first question in this exam was what is the empirical formula of butane? So first of all, reminding you again, empirical formula means the formula showing the simplest ratio between the atoms. So first of all, what is butane? Butane is this kind of alkane in which we have 4 carbons. So this is C4H10. Now, what would be C4H10 is the molecular formula, but he's asking for what is the empirical formula. So if we simplify the ratios of 4 to 10, then the empirical formula is C2H5. Okay, so the next question says, when zinc is added to copper sulfate solution, copper is formed. Which of these is the best name for this type of reaction? Remember, if I have zinc plus copper sulfate to give zinc sulfate plus copper, what kind of reaction is this? This is referred to as a displacement reaction in which zinc is more reactive than copper, so it will displace it and copper will be formed. Now, this next question is asking about the ionic half equation for a process that takes place during this reaction. So during the reaction of zinc plus copper sulfate to zinc sulfate plus copper, which of these options can be one of the ionic half equations? Remember, how do we write ionic half equations? We said, just to revise, if I have a symbol equation, it is balanced. Now, if I want to write the ionic equation, we said we will ionize whatever is aqueous. So zinc is a solid, it remains as it is. But copper sulfate is an aqueous solution, so it can be ionized into copper ions and sulfate ions. Zinc sulfate is aqueous, so it will be ionized. Copper is a solid, it's not ionized. And then the next step would be to cancel whatever is the same on both sides of the arrow. So this is actually the net ionic equation that we have for this kind of reaction. So which of these half equations applies here? Now what is happening? The zinc has changed to zinc 2+. That means it has lost 2 electrons. And the copper 2+ will need to gain 2 electrons in order to form copper. So which of these options is correct? It is the one where we have the zinc losing 2 electrons to form zinc 2+. How many molecules are there in 44 grams of carbon monoxide? Now, you should realize that we said in order to get number of molecules, I need first to get the number of moles. Now, how do we get number of moles? He's giving me 44 grams. That means I will use the equation that involves mass over molecular mass. The mass here is 44. Remember, this is carbon monoxide, so that means 1 carbon and 1 oxygen. And the total number of moles in this case is 1.57. Now, how many molecules? You know that in order to get the number of molecules, we multiply number of moles by Avogadro's number, so this would be the correct answer. The next question says a compound has molecular mass of 84 and this is its composition. What is the molecular formula? We said if he gives me the percentages of each one, I write it in this way. And then I go through 2 main steps. The first one is divide by the atomic mass of each one. So carbon by 12, hydrogen by 1, oxygen by 16. Now the numbers that come out from these divisions, I divide by the smallest. So which one is the smallest? That's 1.19 or 1.1875. Now these are the ratios that I get, and that means that this would be my empirical formula. So the C5H8O now is the empirical, but he's asking for the molecular formula and he tells me the compound should have a molecular mass of 84. So in this case, I try to find out what is the molecular mass of the empirical formula that I just got. I have C5H8O. The molecular mass of that from the calculation will come out to be 84. And that's what he's saying the compound has anyway. So that means that the empirical formula is the same as the molecular formula. Okay, the next question says the formula of barium chloride is BaCl2. What is correct for barium chloride? So let's look at each one. He's saying barium chloride exists as a molecule. Now, you know that barium chloride is supposed to be ionic. So we cannot say that this is correct. Now, he says barium chloride is a compound. Yes, that would be my answer. Barium chloride is a compound. Let's check the others. Empirical formula for barium chloride is BaCl. No. BaCl2 is the simplest ratio between the elements, so you cannot just remove one of the chlorines. He says the MR of barium chloride is this. Well, let's calculate it, but it comes out to be the wrong answer. So from all of these, barium chloride is a compound would be the correct answer. The next question is talking about mass spectrum of an element. Again, when he gets a mass spectrum, we pay attention, first of all, is this an element or a compound? Now, this is an element means that I have isotopes. So the peaks that I have there represent isotopes. And the first question says, what is the atomic mass of the. So looking back at the graph, I find that I have the two highest peaks at m over z. We have a peak at 63 and a peak at 65. And each of these, I have to look at its abundance, its relative abundance. So that first peak at 63 has an abundance of 46. The peak at 65 has an abundance of 20. So in order to calculate it, I do this. But then the total abundance is not 100. So we used to say the mass times the percentage plus the mass times percentage over 100. This is not a total of abundance of 100. This is a total of 66. So actually this is over 66. So that means that the atomic mass is 63.6. Which species could be responsible for the peak at m over z 32.5? Well, I want something that will have a mass of 32.5. First of all, we're not talking about sulfur because we just said that the atomic mass of the element is 63.6. This is not sulfur. So sulfur is not an option here. And anyway, sulfur has a mass of 32, and if you divide 32 by 1, it's not 32.5, so that doesn't apply. Now let's look at B. B says 63 copper 2 plus. So if it is copper 2 plus, then the m over z would be 63 over 2. That's 31.5, not 32. So this is not the one I'm looking for. Now C says it's a copper 2 plus and it has 65. Now 65 over 2 is 32.5. So actually the one that has a mass over Z of 32.5 is the copper 2 plus and not any of the other options. Here he's saying what is the molecular formula of this compound. Now we know that this is called a skeletal formula, and any junction between two lines is actually a carbon. So this is actually the compound that we have. Just count the number of carbons and hydrogens and oxygens. So that comes out to be C4H2O4. So that is the molecular formula of this compound. Here he says I have a sequence of 4 molecules with skeletal formulas, and he's saying what is the molecular formula for the 5th molecule in the sequence. First of all, you know that anything that has an OH is an alcohol. The skeletal formulas means that we have carbons and hydrogens that are implied in each structure. So that first structure is actually this. So the molecular formula of structure 1 is C2H6O. Now, this second one is actually this. And that means this is the molecular formula, and so on. If you look at how many carbons, how many hydrogens, how many oxygens, so it is C2H6O, C3H8O, C4H10O, C5H. So actually, this is the same general formula as alkanes, but just add an oxygen. So what would be the molecular formula of the fifth one? The fifth one will be this is C5H12, so this would be C6H14O. Okay? What is the name of this type of sequence? Having a group of organic compounds having the same functional group, having the same general formula. This is called a homologous series. Which ion does not have the electronic configuration shown? Okay, so what is the electronic configuration shown? If you look at the number of electrons here, these are a total of 18 electrons. Now, when we have 18 electrons, he's asking which of these does not have 18 electrons. So let's take a look at potassium. Potassium K has 19. If I have K plus, that means they are 18. So this would apply to it. He's saying which one does not apply to it. Calcium is 20 with a 2 plus, it would be 18. Scandium is 21 with a 3 plus, that would still be 18. Titanium has 22, so if I remove 2 electrons, there will be a total of 20, not 18, so it will not have this electronic structure. Okay, what is the electronic configuration of the nitride ion N3 minus? Well, N3 minus, you should know that N has 7 electrons, so 3 minus means it would have a total of 10. Now, how do we distribute 10 electrons? This is it. Okay. Which of these ions has the smallest ionic radius? Again, if I look at the periodic table and I compare all of this, we look at how many protons and how many electrons in each of these. And what we're looking for is, we're looking for something that has a big number of protons attracting a certain number of electrons. So if we look at this, aluminium has 13 protons, attracting 10 electrons. Now, gallium is very big. Gallium is, first of all, gallium as an atom is in period 4, and then when we remove the 3 electrons, it will have 18 electrons. So it actually has more shells, so it is bigger than aluminium, for example. Magnesium will have 12 protons attracting 10 electrons. Fluorine has 9 protons attracting 10 electrons. So if we say gallium is too big, then we're comparing aluminium, magnesium, and fluorine. They all have 10 electrons. Again, we said these are isoelectronic. Now, the one that is smallest is the one that has more positive charges in the nucleus attracting these 10 electrons. So the aluminium would be the smallest of these options. Okay, what is the percent atom economy by mass for the production of hydrogen in this reaction? And we said again, how do we get percent atom economy? Percent atom economy is the molecular mass of the required compound, so for the required product, for example, molecular mass here of hydrogen, over the total molecular mass times 100. That's how we get atom economy, percent atom economy. So in this case, the molecular mass of what we have is 6 because we have 3 hydrogens in the product. So we have 6 over the total MR of carbon monoxide plus the hydrogens times 100. So this comes out to be 17.6%. How many lone pairs of electrons are there in the outer shell of the sulfur atom in a molecule of H2S? Well, if you remember how we drew H2S, we said S is in group 6, so it has 6 electrons in its outermost shell. It needs 2 more, so it will share 2 of its electrons with 2 hydrogens. And then it has how many lone pair of electrons? We have 2 lone pair of electrons. Remember that every 2 electrons is a lone pair. Which equation represents the third ionization energy for an element? Okay, again we said third means I'm starting with something that has 2 positives and I'm removing an electron to form 3 positives, and everything has to be in the gaseous state. So that is the third ionization energy of J. In which sequence are the molecules in order of decreasing bond angle? Again, please pay attention to these questions. Is he asking about decreasing or increasing? So we're looking at something that is in order of decreasing bond angle. Well, let's take a look at the bond angles of each one. Now, what is BeCl2? BeCl2 is beryllium with 2 chlorines, 2 bonding pairs, no lone pairs on the central atom, so the bond angle is 180. BeCl3, B boron with 3 chlorines, so I have 3 bonding pairs of electrons, again no lone pair on the central atom, so this is what we call trigonal planar, and the bond angle is 120. Now CH4, we said these are 4 bonding pairs of electrons, so this is a tetrahedral with bond angle 109.5. So if we're looking at this sequence in A, this sequence is in decreasing bond angle from 180 to 120 to 109. So this would be the correct answer. If I look at the others, we have beryllium, chloride, ammonia. You remember that ammonia is 107. So if we're looking at 180 and then 107 and then 109, that's wrong. That's not the correct sequence. So actually the answer is A. Which pair of ions will form the compound with the most covalent character? So the choices that I have are things in group 1 and things in group 7. Remember that group 1 with group 7 tend to form ionic compounds. So the compound should be basically ionic. But we said in some cases it will have some covalent character. So which one will have some covalent character? The one that, if I'm looking at group 1, the one that is least reactive. So the more reactive metal, which is the one at the bottom. So rubidium in this list is the most reactive metal. If I have a very reactive metal, it will do ionic, not covalent. So in group 1, lithium, sodium, potassium, rubidium, which one is more likely to form a covalent character? It will be the lithium, the less reactive metal. Now, in group 7, remember that the reactivity decreases as I go down. So in group 7, iodine will be a less reactive non-metal. So lithium with iodine would be more likely to have some covalent character. But if we have a reactive metal and a very reactive non-metal, they will tend to form more ionic than covalent character. Okay, which diagram best represents the electron density in a molecule of hydrogen chloride? Remember, hydrogen chloride is a covalent compound. So A is wrong. If they're separated like this, that's ionic. That does not apply to hydrogen chloride. C also is wrong because they're not the same size of atoms. Remember, hydrogen has only 1 shell, chlorine has 3 shells. So chlorine should be much bigger than hydrogen. It's not B because the electrons are not being shared equally between them, since chlorine is more electronegative. So what we have is D. That would be the correct representation of the electron density. Okay, in section B, this is the first question. State what is meant by the term orbital. You should remember that an orbital is a region within an atom where there is a high probability of finding an electron. This is the place in the atom where we can find an electron. state the shape of an s orbital and the shape of a p orbital, you have to remember that an s is spherical. The p is what we call dumbbell shape. So the s looks like a ball, we say it's spherical, and the p is dumbbell shape. Describe what can be deduced about the electronic structure of sodium from its successive ionization energies. So if we look at the successive ionization energies, first, second, third, fourth, and so on of sodium, what will that tell us about the electronic structure? You should remember that if we look at the periodic table, sodium has 3 energy levels. It has 1 electron in the outermost shell. So if I'm looking at the first ionization energy, after the first ionization energy, there will be a huge increase in the ionization energy, and then a gradual increase, second, third, fourth, fifth, sixth, until the 9th ionization energy. Then we will have a huge increase in the ionization energies, because then you would have removed all the electrons in that second shell, and you're going into the innermost shell, which is very strongly attracted to the nucleus. Okay, here we say the log of the 4th ionization energy for 6 elements is shown. Again, remember that when we try to plot ionization energies, we always plot them as a log of the ionization energy. This is because the ionization energies are usually a very large number, so it is very difficult to plot them on a graph. They will not fit on a graph. So we look at the log of the number, and that's what we put into the graph. So he's saying plot a graph of these data. Again, the first thing you do is label the axis. What are we looking at? We're looking at an element and its log. So we said what is on the left of the table goes down. So down you can say element, or you can say atomic number. So either we're going to write them as elements, or we're going to write them as atomic number. And the log of the ionization energy will be on the y-axis. Now you need to distribute the numbers so that you use as much of the graph paper as possible. So this would be the most reasonable distribution of the numbers. First, we plot all the numbers with a small x or a small dot with a circle, and then we can join them. So this is our graph. He says, use your graph to estimate the 4th ionization energy for sodium. They did not include sodium. Sodium is something that has atomic number 11. They don't have a value for 11, so we get that value from the graph. From 11, you go up to the graph, and then you go horizontally. It comes out to be about 3.995. That means that the log, that's from my graph, log to the power 10 of the 4th ionization energy is 3.995. So what is the ionization energy? Remember, if you want to get the number now, the number is actually 10 to the power of whatever you got. So it's 10 to the power of 3.995. If you do that with a calculator, it comes around this number. Suggest why the 4th ionization energies of neon and sodium are similar in magnitude, even though the elements are in different periods of the periodic table. If you look at the periodic table, neon and sodium, if you find the 4th electron will all be from the same orbital, which is the 2p, and that means they are similar in magnitude, or that's why they are similar. Okay, now he has a compound, ammonium dichromate. He says it breaks down at around 180, producing an oxide of chromium, nitrogen, and water as the only product. So write an equation. That means you're starting with the ammonium chromate. You are forming an oxide of chromium. So this would be chromium 2O3. So that's chromium valency 3 plus nitrogen plus water, and you balance all of this, and this comes out to be the equation. Give the name for this type of reaction. When we heat something and break it up, this is called thermal decomposition. Here he's saying when this number of moles of ammonium dichromate was heated, 25.2 centimeter cubed of nitrogen gas was formed. Calculate the temperature. So if this question is asking for, usually they ask for volume or pressure or number of moles. He's asking for temperature in this case, and we can get it from the ideal gas law. So we know that from that law, temperature would be equal to PV over NR. Now, what is the P? P, he says the pressure is 101 kilopascal. In order to put it into this equation, it has to be in Pascal. So I have to multiply it by 10 to the power 3. Then we want to multiply it by volume. What is the volume that we have? The volume that we have is 25.2, but then that is in centimeter cubed. Remember, for this equation, you have to convert it to meter cubed. So you multiply by 10 to the minus 6, or you divide by 10 to the 6. Now, over number of moles is that number, 0.001, times the R, which is 8.31. That comes out to be a temperature in Kelvin. Remember that the temperature that comes out of this is in Kelvin. He is telling me that he wants it in degrees Celsius. Remember, to change Kelvin to Celsius, you subtract 273. So 306 minus 273, and that gives you the temperature in degrees Celsius. Okay, draw a dot and cross diagram of the ammonium ion. Remember that ammonium means I have nitrogen with 4 hydrogens around it. Now the nitrogen is in group 5. That means it needs 3 electrons, so it is sharing 3 electrons with 3 hydrogens. But then the ammonium ion is formed by forming a dative bond with an H plus. So that means that one of these hydrogens will have both electrons from the nitrogen. So in this case, in my diagram, the hydrogen below is the one that has 2 electrons from the nitrogen. So that is a dative bond, while the others are a pair of electrons, one from each atom. And of course, do not forget that this has an overall positive charge. Explain the shape of the ammonium ion using electron pair repulsion theory. Remember that this is something that has 4 bonding pairs of electrons with no lone pair on the central atom. So that means that it would be tetrahedral, and this is for minimum repulsion between the 4 bonding pairs of electrons. Here he's giving me information about ammonium dichromate, and he's saying choose the hazard symbols that will apply to this compound. So he's saying this compound is toxic. First of all, which of these hazard symbols indicates that the substance is toxic? Remember, it is that sign with a skull at the bottom. So that indicates that the compound is toxic. So a bottle of ammonium dichromate would have this symbol on it. He says handle with extreme caution. Where is extreme caution? That question mark there tells you to handle with extreme caution. Contact can irritate and burn the skin with possible eye damage. That means it is corrosive. So this sign indicates that it is corrosive. Inhaling can irritate the nose and the throat. Ammonium dichromate is a strong oxidizer. Which one would say it's an oxidizer? There are 2 similar symbols there. This one is oxidizer. The other one on the other end at the left indicates that the substance is flammable. So that is the symbol for oxidizer. So just why ammonium dichromate is not stored in the same cupboard as alkanes. Now remember that alkanes are flammable. So do not put something that is an oxidizing agent next to it, because that would mean that it will cause it to burn. So alkanes are flammable, and ammonium dichromate is an oxidizing agent, and that will help in combustion or enhance combustion. Okay, this one is about polymers, and he's saying we have polylactic acid, which is biodegradable. Lactic acid is obtained from corn. An equation for the polymerization of lactic acid is shown. So you can see that lactic acid is something that has OH on one end and an acid group on the other end. So this is the polymer. If you remember from um, the O-level subject, this was called condensation polymerization. But what we're supposed to remember very well this year is the addition polymerization. So he's telling you write a balanced equation for the polymerization of propene. So remember, propene, what does propene look like? Propene, and he's saying using displayed formula. Propene is something that has 3 carbons, so this would be the displayed formula of propene. When we form a polymer, we remove the double bond and we put bonds on sigma bonds on both ends of the carbons that have the double bond in order to join to other molecules of the same kind. Remember that he says write a balanced equation, and that means I will be starting with n number. Can you see that small n before it? N number of propene molecules, they will join together and will form a long chain in which this repeat unit is repeated n times. So we put a bracket with a small n around the product. Give one difference between polymerization of propene and that of lactic acid. So remember, if we're looking, we said lactic acid is the first one that he wrote for me, and we said this is condensation polymerization. And in condensation polymerization, when we join the monomers, we remove a molecule of water. So this product gives you a molecule of water, while the one with propene gave only the polymer. Only the polymer is the product, no removal of small molecules. So the difference between them is that a molecule of water is formed in polymerization of lactic acid, but not propene. State the meaning of the term biodegradable. What does biodegradable mean? Biodegradable means can be broken by bacteria. And if you remember, we said polymers are non-biodegradable. So most polymers cannot be broken down by bacteria. But if he says that something is biodegradable, then that means it can be broken by bacteria. Give 3 advantages of biodegradable polymers. Remember, when we talked about the non-biodegradable polymers, they were bad because they accumulate in dump sites. If they are burnt, they release toxic gases. So what if we are using biodegradable? In this case, they can be broken down by bacteria, so there will be less accumulation of waste in dump sites. They will not sit there in landfills for years and years. They will be broken down. So that's one advantage. We do not need to burn them, or they do not need incineration. Remember, the word incineration means burning, and that means they will not give out any harmful gases or toxic gases. They are made from renewable resources, so they help to conserve our crude oil reserves, so we don't need to use up the crude oil reserves to make them. Okay, isoprene is used to make synthetic rubber, and he gives you the skeletal formula for isoprene. State why isoprene does not have geometric isomers. Again, remember, we said geometric isomers are the ones in which we said we have cis and trans, or E and Z, and these happen when we have a double bond, and the carbons on the end of the double bond, each one is connected to 2 different groups. Now, he's telling me that isoprene does not have geometric isomers. This is because if you look at the double bonds will have 2 hydrogen atoms on one end, so they don't have different atoms attached to each carbon. A related molecule does show geometric isomerism. Draw the geometric isomer of this molecule. Now, if I look at this molecule, I have the chlorine on one end of the double bond on the right. The chlorine is the higher priority. Now, on the other end of that double bond, there is something that is bigger than the methyl group. So this is actually a trans. So if I want to draw a geometric isomer, I would draw the cis form. So that would be the other isomer. Give a reason why double bond may result in geometric isomerism. Remember that if I have a carbon-carbon double bond, there is restricted rotation around the double bond, and that is why if each of these carbons is attached to two different groups, then they can be either a cis or a trans. Here he's saying this question is about liquids of cyclohexene and bromine. Calculate the volume in centimeter cubed of this number of moles of cyclohexene and give your answer in appropriate number of significant figures. And he gives me among the data is the density of the cyclohexene. Okay, he wants volume. Well, how am I going to get the volume? The density is mass over volume. So I can get the mass. If I get the mass, I can get the volume using the density. How do I get the mass? I can get that from the number of moles. So if he gives me the number of moles and the mass is number of moles times mR, so it's 0.03 times the mR of C6H10, he already gives me the formula up there. That would be 2.46 grams. That means that my mass is 2.46. I can use the equation for density. We know that density is mass over volume, so the volume would be the mass over the density, and that gives me a volume of 3 centimeter cubed. Remember that he gives me the density in gram per centimeter cubed. So that means that my volume will automatically come out as centimeter cubed. Bromine reacts with cyclohexene. State the color change when an excess of cyclohexene is added to liquid bromine. Remember, if we add a double bond, an alkene, to liquid bromine, it changes from reddish brown to colorless. This reaction is very similar to the reaction of ethene with bromine. Draw the mechanism for this reaction of cyclohexene with bromine and include curly arrows and dipoles. Remember, again, when we have an alkene with a halogen, this is called electrophilic addition. The double bond attacks the slightly positive end of the Br. Remember, if we have the two Brs, then we write a slightly positive charge on one of the Brs and a slightly negative on the other. So the double bond attacks the positive. The two electrons in the bonds between the bromines go to the other Br, and I end up with a positive charge on the carbon and a bromine with a complete negative charge and extra electrons. These extra electrons then attack the carbocation or the carbon with a positive charge to add the second bromine. So that would be the mechanism. Here this question is saying state the meaning of ppm. First of all, you should know that ppm means parts per million. Then he says at the top that bromine vapor in the atmosphere can cause irritation to the eyes at a concentration of 1.1 ppm and to lungs at a concentration of 10 ppm. Remember that if you have these kinds of two numbers, the precaution that I would take would be from the 1.1 ppm, from the smallest that can cause any irritation. So I don't want 1.1 ppm of anything in here. So when he says a sample of 3.25 centimeter cubed of bromine vapor leaks into a laboratory, calculate the minimum volume in decimeter cubed of the laboratory for the resulting concentration of bromine to be at a safe level. Okay, he says if it is 1.1 ppm, it would be dangerous. So I want to see if I have a sample of 3.25 centimeter cubed of bromine, what could be the total volume so that my amount of bromine is not hazardous to whoever is in the lab. We know that calculation of ppm says the amount over the total times 10 to the 6 is parts per million. So the amount that I have, 3.25, but this is in centimeter cubed and he wants it in decimeter cubed. So 3.25 I multiply by 10 to the minus 3 to change it to decimeter cubed. So that amount over the total volume of the lab that he's asking about times 10 to the 6, it should be 1.1. And from that, you can calculate what is the volume of the lab. The volume of the lab comes out to be about 2955 decimeter cubed. Because bromine is so hazardous, it is usually used in the laboratory in aqueous solution. A sample of bromine reacts with exactly 0.03 mole of cyclohexene. Calculate the minimum volume of water needed to completely dissolve this sample of bromine at room temperature. Now, he gives me that the concentration of bromine in water at room temperature is 35 grams per decimeter cubed. That means if I have a decimeter cubed of water, I will need to dissolve 35 grams of the bromine. Now, if we have a sample of bromine reacting with 0.03 mole of cyclohexene, remember that cyclohexene is something that has one double bond. So if he says I need 0.03 mole of cyclohexene, then the number of moles of bromine is exactly the same, because I need 1 mole of bromine for 1 mole of cyclohexene. So the number of moles of bromine that I have is 0.03. Now, what is he asking about? He wants the mass of the bromine. Mass is number of moles times mR. So number of moles, remember this is bromine, that means it's Br2. So it's actually the atomic mass times 2. And that comes out to be 4.79 grams. So I am dissolving 4.79 grams. Now, he's telling me that 1 decimeter cubed of water will dissolve 35. So how much of water will I need to dissolve the 4.79? So this is a straightforward cross multiplication. So 4.79 over the 35, that gives you a volume of 137 centimeter cubed. In the upper atmosphere, ozone can react with halogens and with halogen-containing compounds such as molecule X. Now, name molecule X. How am I going to name this? Remember, this is something that has how many carbons first? It has 2. So this is something ending with ethane. Now, what do we have on the ethane? Because we have a single bond, that's an alkane. Now, I have chlorines. Remember that I have how many chlorines? I have 3 chlorines. So that is trichloro. Now, what is the position of the chlorines? I have one of the chlorines on the first carbon and another on the first carbon and a third on the second carbon. So this is actually 1,1,2 trichloroethane. Remember, we count from the side that will give the lower number. The CCl bond undergoes homolytic fission. Remember, what is the essential condition needed for a homolytic fission? We said if I want the bond to break with homolytic fission, it would need ultraviolet light, just as the halogenation of alkanes. Write an equation for this fission in molecule X. Now, what is he asking? He wants to break a carbon-chlorine bond, one of the carbon-chlorine bonds in molecule X. So how does that break? We said it's homolytic. Homolytic means the bond between the carbon and chlorine, I'm going to break it and give 1 electron each to the atoms on both sides. So I give 1 electron to the carbon, 1 electron to the chlorine. So I end up with a free radical that has this chloroalkane plus a chlorine radical. Then he says, write an equation for the reaction of a chlorine free radical with a molecule of X. Okay, So if I have a molecule of X, so that's a molecule of X, I'm trying to react a chlorine radical. So this is just like the propagation step in the halogenation of alkanes. So what we're doing is we're breaking one of the bonds between the C and the H with homolytic fission, and that means I end up with a free radical on the chloroalkane, and the hydrogen radical will join with the chlorine radical, and my other product is HCl. Write an equation using displayed formula for a free radical formed in this sequence to give a molecule with the formula C4H4Cl6. So basically he's telling me that he wants the free radical that we got from that bottom equation that has the chloroalkane. Instead of having 2 carbons, 2 hydrogens, 3 chlorines, I want double of that. That means I need 2 of these joining together. So actually I have 2 of these joining together to form something that has 4 carbons, 4 hydrogens, and 6 chlorines. Can you see where they join? They join from the 2 carbons that had the free radical. So actually that second free radical has to turn around and join with the first free radical. So this is the compound that we get. What is the type of reaction occurring in this equation? And name the product with this formula. Now, what is the type of this reaction? This is called the termination step of this free radical. Now, what would be the name of the product? The name of the product would be what? 1, 2, 2, 3, 3, 4 hexachlorobutane. Can you determine that? 4 carbons, butane. 6 chlorines, hexachloro. On which carbons? Count from the side that gives you the lower numbers. So 1, 2, 2, 3, 3, 4 hexachloro. And that's the end of the paper. I hope that you feel more confident now as you answer the questions. And thank you for listening to this video.